If you want to know the best way to work with data in your .NET projects, you need to understand the differences between Entity Framework and Dapper. Hi, I'm Patrick from the .NET Web Academy, and in this video I'll compare Entity Framework and Dapper side by side. I'll show you the code for all CRUD operations and run benchmarks to find out which one is faster and maybe better for you. Let's jump in. Alright, now as you can see, we're here in Visual Studio already, and I just created a console application, but this should really be a guide for beginners, maybe also intermediate developers like you. So let's first talk maybe about ORMs. What is an ORM? Because in the end, Entity Framework and Dapper are ORMs, so they really fit into this. Now, in general, an ORM or Object Relational Mapper helps you work with a database using objects and classes instead of writing complex SQL queries. It's like a translator that helps your .NET code to talk to a database more easily, let's say. Now, Entity Framework and Dapper are both ORMs, but they work a bit differently. Entity Framework, made by Microsoft, is a full-featured ORM. It helps you to do things like query data with LINQ, track changes automatically, and handle data updates easily. It makes your life simpler by doing a lot of the work for you, but can sometimes be a bit slower because it does so much. Now, Dapper is called a micro ORM. It's lighter and faster because it focuses just on mapping data from a database to objects. Dapper gives you more control, so you can write your own SQL queries if you need to. It's great when you need speed, maybe, and if you don't want any extra overhead. So now I show you how to use both Entity Framework and Dapper for all CRUD operations, which means creating, reading, updating, and deleting data. And then we'll run some tests or benchmark to see which one is faster. So whether you need the power of Entity Framework or the speed of Dapper, in this video you will find out which one is right for your projects. So let's dive into the code and see how all works. Again, we have a console application here. So far we have the program CS and a game character, because what I want to do is just create a simple console application where we create, read, update, and delete game characters. As you can see, we've got a game character ID, character name, power level, and the weapon. Nothing fancy. It could be anything, a product for an e-commerce app, for instance, but I think video game characters are more exciting. Now, before we start adding more code, we need some packages. So let's start with Entity Framework. We right-click our project, manage NuGet packages, and here we go to Browse, and then we start with Entity Framework. It is Microsoft Entity Framework Core. Maybe you already know that the core term internally is still used, but actually it's dropped since .NET 5 actually. Until then it was called .NET Core, but now with the unification of .NET Standard and .NET Core, we only have .NET, but still internally you see Entity Framework Core is the name. Additionally to Entity Framework Core, we also need SQL Server. In my case, because I want to use a SQL Server database, SQL Server Express to be more exact. Really don't want to dive deep into that, but if you are starting also with SQL Server, then please just Google it, all right? So Google SQL Express, you can download it for free, and then maybe also SQL Server Management Studio, because this is the tool I use to check out the databases in the end. So SQL Server it is. Let's install that as well. And the last one, because we're also using code first migrations, is tools, because with that thing we get a bunch of commands that we can use to add migrations, and we actually only add one migration here. So we have our game character ready, we have the program CS. Now to make Entity Framework work with code first migration, we need a database context. So let's add a new item, and this is just our game context, let's say public class. And this thing now inherits from DB context. All right, so this is already stuff you have to do when you want to use the Entity Framework. Maybe a bit more configuration in this case, but again, later on, maybe it's easier for you to grab all your data, make updates, and so on. So here I type control and period. So I get the using directive, save everything. Everything is ordered here now. tidied, cleaned up. Cleaned up is the word I was looking for. And now when we want to see our game character class here, this object in the database, represented in the database as a table, then what we have to do is we have to add a database set. So this looks like that. We add a property of the type DB set, and then we say this is our game character class, and then here we use, or we look for a name for this table, and usually you just pluralize the name of the class. So this is now our game characters table. And then there's also one more thing we have to add, and this is our onConfiguring method. So protected override void on configuring, and this is actually something that you don't have to do here. So as you can see here, DB context options builder, I'm using it here now to add the connection string for our SQL Server database. So here now we say options builder, this is the right one, and then we say use SQL Server. So we know that we want to use SQL Server, and this is why we needed the NuGet package. And in here now I add the connection string, and bear with me here, I copied it, but I will tell you what to enter here. So the first thing, if you want to use SQL Express locally, then this is what you have to enter. Server equals localhost // and then SQL Express. Upon installation of SQL Express, you are asked for the name, but I think by default it's just SQL Express, and this should work. Now comes the database name, in my case simply GameDB. And now we also add trusted connection, set this to true. And since I think .NET 7, you also have to add trust server certificate and set this to true as well. And this is the connection string for your local work here. If you're developing locally, have SQL Server Express installed locally, then this is totally fine. If you, for instance, want to publish this later then to Azure, you can in essence do pretty much the same thing, but what I would do is add an app settings JSON, maybe not in the console application, maybe you have a .NET Web API, something like that, and then you have your app settings JSON file, you add the connection string there, set a name for that, maybe default connection, and then later in Azure you can also set a default connection. When this thing then is published with GitHub and GitHub Actions, for instance, to Azure, then Azure is smart enough to know that you want to use not the local connection string here, but the one that you entered in Azure then. We do stuff like that in the .NET Web Academy, so maybe you want to check it out, but so far this is totally fine for us. All right, with that, we can actually already run migrations, so we see our database in the SQL Server. Let me first open SQL Server Management Studio. All right, here we are. As you can see, there's one database. This is from, again, the .NET Web Academy, so please ignore that. But now we will add our game database here. So what we can do is we just open the Package Manager console and we create our first migration. So this is then add-migration. We hit tab, so you see this command is there. And maybe simply call this initial, because this is our very first migration. And now what .NET will do here is telling me that the build failed. This is amazing. DB context. Actually, we don't need a main. Maybe we can just enter something like console write line hello EF. All right, let's try that one more time. Now the build succeeded. So you see, interesting, you have to add something to the program CS to make this work. But the thing that I wanted to show you is here, this migrations file, all right? It is opened automatically. You see an up method and a down method, meaning when we now apply this, nothing changed so far in the database, but when we apply this, you see in the up method, this is what will happen, and we will create this table, game characters, with the properties or the columns, you name it, a primary key and so on. So everything smart enough to make this work. And the down method is called when we roll back this migration, and in this case, as you can see, we drop the table. So now let's apply this with update. Yes, update database. Even if the database does not exist, this is the command to run. And then we refresh all databases here, and we see now we've got our GameDB. Isn't that beautiful? And we edit the top 200 rows, for instance, and see this is how it looks. Great. So migrations work. And now we can focus on actually making our CRUD operations work. All right, so here first let's start with Entity Framework. For that, I would like to create a repository file or a service, you name it. We don't really use dependency injection or stuff like that. Maybe this is too much overhead. Then we just create an instance of this repository and then you will see all the functions there. So let's add now a new item, and this will be our game character repository. All right, let's make this public as well. Save that. And now first, let's add a constructor. Again, I told you that already, where we create our context. So here now we have a private game, almost a private game context. And maybe just call this context in this case. And here now we say context is a new game context. All right, so with that then we can make use of Entity Framework, and the first thing that I would like to do is create a create method, or use a create method to, well, create a new game character. So how would that look? Let's just say public void, and again, if you would use a web API, maybe you already saw the tutorial regarding the web API with Entity Framework and SQL Server. Pretty similar stuff, but here I wanted to focus on just the methods of Entity Framework and Dapper, so way less stuff to think about. And here now, with the prefix EF, because we will also add Dapper, of course, in a minute. So what we have to do is we first just create a dummy character, a mock character, which is a new game character, of course. And here then we say the character name is Link. All right, then we have the power level of over 9000, right? And then a weapon, which is the Master Sword, of course. All right, when we got this, we can only say, or simply say, game characters add character, and then we have to save these changes. So context, save changes, and this is everything. All right, so this is how to create an object with Entity Framework. Now in the program CS, let's do that. Maybe here we say Entity Framework first. All right, and now here we run when we got our context, of course, our repository. So var repository is a new game character repository. Great. And here now we say repository EF create, like that. Now I would say we run this. All right, so here again we can see nothing there so far. Execute SQL, and when I just run this now, we see Entity Framework is doing its magic. We can close this, and now back here, and we see Link has been created. We can do this one more time, and with that then, here it is. With that now we see that the character has been created again and the ID was incremented as well, but this is SQL Server, right? That automatically increases the ID. All right, so this is just creating a character. And now I would say, before we cover all the other operations, let's do Dapper. For that, we need another NuGet package. We manage NuGet packages. Go to browse again. And now we say, Dapper, please. All right, high performance micro ORM supporting SQL Server, MySQL, SQLite, and so on. We only need SQL Server, so we're fine with that. Install this thing, and we should be good to go. So now let's add another method, and this then is public void Dapper create. All right. And now what do we have to do here? We have to first create a SQL connection and then also clean this thing up. So we are using the using command here, or the keyword, with our connection, which is a new SQL connection with a connection string. So as you can see, that you can see now that we also have to add the connection string here. So let me copy this thing from our game context. There it is. All right, let's go back and maybe up here say private read-only string. And this is now our connection string, and that's the one. All right, and here now get our connection string. But now the big difference is that you have to write SQL yourself. So first we have our command. Now this is a string, insert query, and this looks like that. Insert into game characters. And now regarding the columns, we have the character name, power level, and the weapon. All right. And then regarding the values, we've got character name at power level at weapon. So these are the properties of our object, right? So now we say connection execute. We use our insert query like that. And now regarding the object that we want to provide here, it's also again a mock character that we create. So we add a new object here in essence with a character name. Character name is Mario. All right. And then the power level is, now let's say, a bit lower. And regarding the weapon, we use the fire flower. All right. Now, one more thing that is important here. And this is an object that I just added here on the fly. So these properties here, they have to match this stuff here, right? So character name, power level, weapon, and so on. You really have to make sure that this is the same. Otherwise, this will not work. But still, maybe you can already see here that you have maybe more control over your SQL statements. You also have to write your SQL statements. And you have to maybe pay more attention. But again, whatever works for you. This is the method. Now let's go to the program CS again. And then we say here that this is now Dapper in action actually. So here it is Dapper. And we run repository Dapper. Dapper. When you write repository correctly, Dapper create. There it is. All right, now let's run this again. Okay, Entity Framework and Dapper was run. And now we hit execute SQL, and you see now we've got Mario. Link, of course, again, Mario with the fire flower. Now what happens, just to test this, when I now say in the repository, I have a typo here. It's no weapons, all right? We actually get an error, right? Must declare the scalar variable weapon. So you see this would not work. Of course, you get the proper error message, so you see what is actually wrong here. But when I now say weapons here as well and run this, then you see no error anymore. We go to the database, this thing here, execute SQL, and again, this works. All right, but now let's just say this is the weapon. All right, I think this is all right, this is enough for a first presentation. So now let's continue creating all the other CRUD operations so you see them side by side. Okay, now first reading, I'd say. We make CRUD operations, so read would be the next one. And since I'm lazy, let me just copy and paste some stuff. So here we've got EF read now. And what I want to do is, again, get a character. But here now I say this is context characters, game characters actually, and give me the first or default one where, and now you see I can use link, so where the character, C for character, character name equals link. All right, that's it. So now with that I got the character, and now we can write it, of course, into the console. So write line, and now here with string interpolation we can get our values. So let's say the character now is character name. Then we've got the weapon, which is the character weapon, of course, and the last one, the power level. So power level, actually power level was first, right? Anyways, I think you know what I mean here. So power level it is, and this should be it. So this is how we read an object with Entity Framework. And now Dapper public void Dapper read Thank you, IntelliCode. Really smart. And now here, what we do is, again, we need the connection here. All right. And now here we have our read or select query actually. So select, and here now this would be select everything from our game characters table, where the character name now is at and then character name. So you see what I didn't tell you here with this at sign, you can parameterize your queries, helping against SQL injection. So now the result var character is connection. In this case now the function would be query first or default. We want a game character, so this is what we have to specify here. So Dapper knows, okay, whatever is the result then from the query, I or the user wants to map this to a game character. And now here we have our select query, and regarding the parameter, again, this is a new object with now only the character name, and this time we want to get Mario. All right, and then let me just copy and paste the logging actually. So copy this, and now here, nope, in the read method we say console write line, and again the same stuff. All right, now we also have to run this, of course. So here repository ef read, and now repository Dapper read. And yeah, I know I told you I want to implement everything first, but let's just see that. And as you can see, this worked great. So here now, this is the result with Entity Framework, and this is the result with Dapper. All right, update is next. So back to the repository, we go here. So public void ef write, nope, not really right. Let's call this update now. And for this example, we first need a character, right? So maybe we can actually copy this from the read method. So we got a link, and now I want to change something. So what we can do is I just check if the character is null or not. And if not, we say that the character weapon now is link's shield maybe. All right. And we have to run context save changes. All right, that's it. See that? No SQL, we just say the weapon now is different. We save the changes, done. Okay, now Dapper. You know, public void Dapper update. Again, we need the connection. And now instead of first receiving the character, we can actually already run our update, right? So here, this is now actually an update query. Update query. And now let's say update game characters, set weapon to weapon. Again, the parameter where the character name is character name. And with that, by the way, we are updating all the characters. This is a big difference actually. But yeah, if you would run this only one time with all the CRUD operations, then you only have one object, so there is no difference. But you see, you have to pay attention here, right? What you actually are going to use. Now in Entity Framework, this would look a bit differently. Again, here in Dapper, we update all characters where the name is like the character name, the parameter that we will add in a second. But here now in Entity Framework, now maybe this is a bit more that I actually wanted to tell you, but here we are getting the first one. If you want to get all the characters, then you would actually have to do something like the following, where, and then add this predicate here, right? Where everything here, all the characters, name is link, and then turn this into a list maybe, and then you would go through the list and update the names. Still not big of a deal really, and you're only using functions and objects and no SQL, right? So this is really the big difference here. But again, let's focus now on the actual CRUD operation. So here we have our update, and now again, what we actually want to do is, this is our update query, and no, the query is great. Here we want to run this query. So now we say connection, don't get anything back, or we get something back, the lines that are affected by this update query. So execute, as you can see here, when you have no error, execute, and now this says it returns the number of rows affected, right? So it's just an integer. You can check for that, of course, if you know that you only want to update one row and there has to be one row updated, so you can work with that and ask for the result then. And if the result is different, it's not one, then display an error, throw in an exception, something like that. Okay, so here now it's the update query. And again, regarding our parameters, character name is Mario, and the weapon now is the superstar, maybe star, like that. All right, that's the update. Long story short, right? Now in the program CS, let's add an update and the read again, so we see that something has changed. So first the update and then again the read, repository, and then EF read, and same thing here. So repository Dapper update and then repository Dapper read. Okay, now let's run this, and yeah, this works. So you see first we have link with the master sort, and then this changes to the Hylian shield, then the Fireflower with Mario, and after that the superstar. All right, and when we check the database now, you can see it here. This is what I was trying to tell you, that we get the very first link character, weapon has changed, but the rest still has the master sword. And Mario here, we got all, or we updated all of Mario, all Marios in the end, and set the weapon to a superstar. So again, this is really something to pay it, to be careful to. This is something where you have to be careful and pay attention. All right, last thing, delete. So back to our repository, we go up to entity framework. Here we have public void ef delete. All right, and now again, actually, we need a character first, so that we know which character we want to delete. And again, we only get the first one, so we're only deleting one link here. Again, if the character is not null, we say that context game characters should remove this specific character. And again, we say save changes, and that's it. All right, so with that, we return, or we remove our first link. And now here for Dapper, public void Dapper delete. What do we have to do here? Again, the connection, very first thing. We have a delete query now, so delete. And here we delete all the Marios again, so delete, or it's affecting all the Marios. So delete game characters, and now here, no wait, delete from game characters actually, delete from game, yep, this is the right one. Delete from game characters where character name is a character name, and again, we have the delete query, and the character name is Mario. Save this, and here in the program CS, we run repository ef delete and repository Dapper delete. All right, we run this again. There's the result. All right, this is correct because we already have the entries here. And then we check out the table, execute SQL, and as you can see, only link is left. But what if I delete all the links, execute SQL, and if I run this now, we should see no change actually, because we should only create one character or one link, update link, delete it again, and then Mario, updating Mario, deleting Mario again, and we close this, execute SQL, nothing is there. Great. So these are all the CRUD operations, but now benchmark. I got another project for that. So to save you time, really. All right, now this is the project. As you can see, it's pretty similar, right? You have the migrations, we have the game character here, we have the game context, but we have no repository. I just created the benchmark test file here, or the class, and for that I am using the benchmark.net package. Apart from that, everything should be pretty similar. We have the same connection string, but we need the global setup. And then run the methods. Again, these are exactly, I think these are exactly the same actually. So there is a difference. Of course, short disclaimer, I'm not an expert pro regarding benchmarks. So for instance, if you check out the update and the delete methods, maybe this is not a good test because Dapper behaves differently regarding the queries. We saw that before in the video, right? Except, of course, you're jumping to the benchmark here. So welcome back, welcome to the benchmark. And I had to play around with the configs because on my machine, it sometimes did not work. So first I had to add this in-process emit, or this in-process toolchain, because of Windows Defender. Doesn't work with that, or with Dapper to be more exact. And the other thing was that sometimes Entity Framework took too long to run this, so I set the iteration time to 300 milliseconds. By default it's 500 milliseconds, and then it worked. So I would just try to run this benchmark again, and then let's see the results. And this will take a long time, but I will jump to it, so don't worry. Real quick, since we are waiting anyways, just wanted to show you that it's really using the database here, so you see how many tests it is actually running and creating, or how many characters it is creating this benchmark now. So you see, in the end, the test is not the best. Maybe I should deliver another one where we then really see a better comparison, I guess, because the commands are different that we are currently running. And actually, to be honest, I wasn't thinking about that until I recorded this video. So bear with me here, please. If you want to see a follow-up here, then please tell me that in the comments, and I try to create a better benchmark. So just for you guys, that you will really see how big the difference then in the end is. Maybe let's just, I know it's not the best idea to run this here since the benchmark is running, but still seems to work. Although, of course, we added only the top 200 rows, so now it would be different, I guess, when we run the select. Let me just do that. Okay, now here we have over 1,000 links, and when I remove that and run this again, we have 34,000 rows. So you see how many characters will be created. All right, back to the benchmark. Okay, I got an error, so let me try to fix this and run this one more time. All right, and after a long time, as you can see here, 10 minutes, and some errors, so I had to restart this again, or not errors, warnings. And again, disclaimer, I'm not sure if this is really the best representation of this, of the speeds of Dapper maybe and Entity Framework, but you can see here that creating, for instance, an entry, which should be fine regarding the test, took 7,000, almost 8,000 microsettings for Entity Framework, and Dapper only 200. So this is a big difference. Regarding reading, this is, well, I think not the best representation really, because I think that in this case, because of the statement that we used here, it's really reading all the entries, and we are really in the thousands here. So yeah, this is better regarding Entity Framework, or faster. Dapper took way longer here, but I think again this is not really the case. Updating, same thing. Entity Framework faster here, but Dapper had to update a lot more entries, so I really have to change that. I'm really sorry about that, but I think I won't record this video again. So maybe this is still something to discuss below in the comments. And then regarding deleting, we see that Entity Framework took way longer actually to delete only one entry, and Dapper deleted all the Marios. Let's have a look at the database. So here we select 1000 rows and we see, well, actually that all the characters are gone. So yeah, I really have to think about this again. Dapper delete all at once, I think. Entity framework, yeah, maybe Dapper didn't have to delete anything later on, but Entity framework did. Because the test was actually to get one character for Entity framework, delete this one. Dapper deleted all the characters the first time, and after that deleted, well, in essence, nothing. There was nothing to delete, maybe because this is the reason why Dapper was way faster. And the update, well, the update is something that could be tested quite often, of course, and we had thousands of entries. Yeah, this makes sense. I'm really sorry, I have to re-record this regarding the benchmark. I will deliver another benchmark. Sorry if you watched the video till now and this is not really a good representation, but maybe you still get an idea, and in particular, maybe you still learned something in regards of implementing all the CRUD operations in Entity Framework and in Dapper. Okay, sorry about that again. I hope still you learned something. If so, please hit the like button. Subscribe to the channel if you want to see more, and in particular the follow-up with the benchmark. And apart from that, I can only say thank you very much for watching. Maybe you want to check out the .NET Web Academy. Link, as always, in the video description. Thank you very much for watching, and I hope I see you next time. Take care.